Hello, Assalamu alaikum. Now we shall move forward from the correlation analysis to the regression analysis. In correlation analysis, our last video, we confirmed that whether there is significant relationship between all the predictors and the dependent variable. In our example, predictors included self-confidence, organizational culture, and designation of the employees in some organization, and the dependent variable is employee performance. Now, regression analysis is the procedure in SPSS which helps the researcher to measure statistics on the cause and effect connections between the predictors and the test or criterion variable. There are two forms or formats of regression analysis at the initial level. One is simple regression, when our model includes only one independent variable x and the dependent variable y. But if we use more than one predictors in a regression analysis, like in our case x1, x2 and x3, three independent variables and the dependent variable y. So simple regression and multiple regression are two basic procedures of regression analysis, wherein we compute statistics about the cause and effect relations between the independent and dependent variable. Now let's go for computing statistical results of the cause and effect analysis. We shall begin with the analyze menu and then select regression procedure from the drop down window, and that this popping up window, and select linear regression. In this box we have the place for dependent variable and the independent variable. In simple regression we shall post dependent variable in this column and then the predictor in the independence column. But we are going to run multiple regression, therefore employee performance will go into the dependent variable, and the three variables of self-confidence, organizational culture and designation of the employees, it will come in the box for independent variables. To have some more statistics, particularly for the collinearity problem in the regression analysis that we discussed in our last video. Collinearity is the problem in the sense that if there is higher correlation between the predictors, then the results are questionable. So for this purpose, different tests are used. For the time being, we shall use a simple test, Durbin-Watson test, which gives the statistics or score about the collinearity, and the standard is that the score should be close to 1. So we shall continue and press OK. Here are the results, the model summary. In model summary, we have to check this R square for understanding the change brought in the dependent variable because of the predictors. For example, here it is 0.551, which means that 55% of change in the dependent variable is explained by the predictor variables. Second is the Anova table and the coefficients table. We shall discuss this here. I have brought those three tables of model summary, Anova and coefficients for better visibility. So here you can see, to answer our research question, and the question is whether or not three predictors are bringing change variation in the dependent variable employee performance or not. So a lot of statistics comes out, but we have to use certain statistics like R square, which is called coefficient of determination, or simply it gives the statistics about how much change has occurred in the dependent variable because of the predictors, and in our case it is about 55%. Durbin-Watson test, as we have said, that it needs to be close to 1 as per experts. So our test gives us 1.3, which is close to 1 and accepted as showing there is no or not noticeable collinearity between the predictors. Anova Table, which gives statistics about the F value and its significance, and if the F value is within the required range, it means that the model used for regression is fit, and it really explains the variation in the dependent variable, successfully explains the change in the dependent variable because of the three predictors. Last, third table, and the most critical important table onto which our decision will be based regarding the acceptance or rejection of the hypothesis. Coefficients table gives us statistics about each variable and its role in the regression process. For example, first predictor, it has significance value, which means it is playing the role. The p value is 0.02, which is less than the required 0.05. Likewise, t score is 2.32, which is far greater than the required threshold of 1.96. Likewise, its beta weight is 0.13. Organizational culture, second predictor, has bigger beta weight. It is the beta weight is the strength of the effect. It's the p value of organizational culture is also within range, less than 0.05. T score is greater than 1.96. And the final third variable predictor, designation, also has beta weight, t score greater than 1.96, and the p value is also significant. Given these statistics, we shall decide that the hypothesis regarding the impact of three predictors on the dependent variable, which is also significant, is there, and it has been proved with the evidence from the statistical analysis of the related data. So that is all about simple regression analysis, and I hope that you must have got a bird's eye view or a simple understanding of what is regression and how it works through SPSS. See you in next video. Khuda Hafiz.